Wait, we need to understand the question first. 25 boys and 25 girls were sitting around a table. We need to prove that there is always at least one person between two girls in all sitting arrangements possible. Now, the person in between can be a girl or a boy. But before we start proving, let's revise something. If we take odd number of digits, for example 1, 2, 3, and pair them like 1 and 2 or 2 and 3 or 1 and 3, one digit always remains alone. But if we take even number of digits, for example 1, 2, 3, 4, and pair them like these, no digits ever remain alone. Back to the question. Can I find a counterexample to prove the statement in the question wrong? Let's find out. Considering arrangement 1, what if no girls sit together? That means they must all be separated by boys. One way to do it is an alternating pattern, something like this. And as clearly seen, this fails as a counterexample, because a boy is always in between two girls. Let's consider another arrangement. In this case, we're gonna make pairs of girls and pairs of boys. And as you can see, we have 25 girls and 25 boys. We will always have a girl and a boy left alone, because 25 is an odd number. Arranging them around the table, it looks something like this. If we consider two boys sitting in position 1 and 2, and the arrangement is in the clockwise direction, the girl with no pair will be in position 50 and the boy with no pair will be in the position 49. Notice it again forms the pattern at one place where the boy in position 49 is in between girls in position 48 and 50. So even this arrangement failed as a counterexample. Now you might ask why I placed only two boys between each pair of girls. Well, you can place 3 or more boys in between each pair of girls, but then you will lose the number of boys even faster and you will be left with no other option but to place all the pair of girls left together. Also, when placing 3 or more girls together, there will always be a girl in between two other girls. Now, the last and the trickiest arrangement. Let's call it the mixed case. Since this arrangement will be made by mixing arrangement 1 and arrangement 2. While arranging around the table, we need to avoid girl-boy-girl pattern so that no boy is trapped in between two girls. Hence, we need minimum of 2 boys in between 2 groups of girls. Let's say we have n number of single girls like in arrangement 1 and m number of paired girls like in arrangement 2. Obviously, m plus n will be 25, which is total number of girls. Arranging the mixed case like this in clockwise direction, we find that the last boy without a pair will be in position 45. And now all the girl groups left will be placed together, and again the mixed case also failed as a counterexample. If you notice, we have taken all the arrangements where there was a chance of finding a flaw, but all failed. Therefore, the statement in the question is proved to be true. Also, check out the question source in the description.